We can see a glimpse of what systems we are doing using advanced sensor technologies, the weapon systems, communication systems, and avionics, stealth technologies. In all of them, there is a scope for generative AI, which I am sure in the inauguration session it was told there are 127 papers. I am sure all these fields will be covered by some paper or the other. So coming to what I would like to talk is whether we can use this in the conference theme, that is in program management, project management, engineering, that is system engineering. In all these things, how we can use. I think it's very fundamental to tell that what project management is, what its scope is, or the time, the cost, quality. Obviously, these are the goals that we need to do, or the key components of project management. So having a complex system where we have multiple sensors, say radars for detecting, IFF, that is identification friend or foe, to identify whether a target that the radar has detected is friend or foe, type of target using sensors like electronic warfare and communication comment systems. Using all these, do a multi-sensor data fusion on board, send the data to the ground for the commanders to take decision using communication systems, whether it is a point-to-point or using SATCOM, satellite communication. So the enormous systems on board, all of them giving the input, whatever output, and from these sensors using multi-sensor data fusion, showing a common operating picture to the users on board or the operators on board to further do, assess the threat, assign interceptors to neutralize the threat, and intercept the weapons towards the adversary aircraft. So these are all the systems that is on board. In all of them, we can use AI and improve the algorithms because the data that is available is enormous. If it is available, we can always improve the model. So as usual in any project, even we were talking over the tea with someone, data is a problem. So go for generative AI so that you can, with available data, you generate further from there and also try to use these. So, but all these complex system of systems need a very good system lifecycle processes. So System Engineering 2023 with IEEE 15288 is a very good process wherein it says an interdisciplinary collaborative engineering management approach that evolves and verifies an integrated lifecycle balanced set of system solutions that satisfies customer expectations. So the aim is to provide solutions which satisfies the customer expectations. And the processes itself is divided into about 30 processes, 2 of them as agreement processes, 6 of them as organizational, and 8 as technical management processes, and further technical processes, about 14 of them. So we also working in aerospace, we need to align to AS 9100 processes and also with a good quality management system. So these being the normal process that we follow, these are the 14 technical processes that is there. And as we can see, we generally use traditionally a V model for the technical processes where from the user requirements, do a system requirement, do a system design, come up to the subsystem requirements, do a subsystem design, come up to the LRUs, then go for implementation, and build it back by hardware-software integration, LRU integration, subsystem integration, and system integration to deliver the final product which meets the thing. So with this kind of approach, if there is any design alternative that need to be looked at the initial stages of the program, you can have as many at the requirements phase. We can always see that it is not as expensive. The cost is not much. But as it goes to deployment phase and if there is a change, the cost of change is very high. And because the systems are so complex, we may not be able to develop and give the solution in the first iteration itself. So we need to build in multiple iterative and recursive solutions, have design iterations built in the time and the cost. So again, using a model-based system engineering, we have to break down the system complex ones into smaller ones which we can handle through different model-based system engineering approaches. Come out to the work breakdown using that processes, and so that will define what is the scope, And also we can add the schedules, resources and constraints from this work breakdown structure. So the workflows that we will have is requirements, the analysis and design, again a detailed design, and allocation to the subsystems, then flight testing. All those stages come in, so those workflows also go on. So in all this, what we do, initiation, planning, execution, monitoring, and of course closing of the project, which is traditionally done. And the different challenges that is available, I think I will not go into it. This is what everybody face, or anybody who's working on a project. But I will just give something what is extra in a R&D environment. See, basically in R&D, it is very, very critical. The effective technology management is very critical. First thing, because of high levels of uncertainty and complexity, because it is the first time that we are developing the system. So we have to adapt the project management techniques to handle this. And there, innovation is involved so that we can improve the technology readiness level. So in our time management, or when we say the project scheduling, we need to add and factor in those things. And this only will ensure that the research projects are completed on time, within the budget, and within the meeting the intended objectives. So here we need to allocate the time frames to include multiple design iteration cycles. So just one iteration is not a production phase where we know what is to be done, multiple. So that timeline, if you don't include, there will be delay in the projects. Rapid prototyping is another way, a spiral development cycle, and of course, a lot of feasibility studies, and we need to do the proof of concept, because many cases the user themselves have not seen a product. It is for them also, it's the first time, and when they communicate what they want, that requirement capture, if it is not in the proper form, English is not their language or our language, it can be ambiguous. So we need to have either at model-based requirements capturing, or also a proof of concept and ask, is this what you meant when you said this? So all these actually require timelines to be added. So we need to have the iteration in user requirements. So one good thing about indigenous system is, since we are developing ourselves, this iteration we are able to absorb within us, and we are able to deliver to the user what they finally want in spite of multiple. And that is where indigenous solutions excel, as against if they go to any foreign or bought out systems, they will not be able to do these kind of iterations out of the contract. And it also involves rigorous testing phase. Not only that, after delivery also, because of the certification requirements, we need to also ensure that continued airworthiness requirements is met. And even in the entire project phase, we also need to give a phase gate approach, that at this stage, if we are not succeeding, this milestone we are not meeting, we should be able to take a call whether we should continue with this project or not. As this morning, the chief guest was mentioning, R&D means there is not necessary that we should be able to succeed in its full form. There may be failures. Failure is not a crime in R&D, because to know that this approach will not give a solution is itself a research outcome which can be used by other researchers to say that, okay, that approach will not be successful. So we need to have enough phase gate approaches also brought in. Similarly, uncertainty and complexity, the time and budget we already talked about. And we also need to have many innovative ideas that are feasible and also should be practically implementable. And many times the users themselves also change their goalpost. So at times, within the constraint, we need to also meet those requirements. And availability of skilled resources is a big problem. And but what we are trying to do is, with partnership with industries and academia, DRDO also has got many projects and many schemes where we fund through technology demonstration and development fund, where about 50 crores is available for a startup if they have got a good ideas. It is funded by DRDO. We have about 15 centers of excellence, DIA COE, that is DRDO Industry Academia Center for Excellence. There again, each academic institute through these centers can approach, and they will be funded by DRDO. So there are many schemes. So even though we would prefer to have many resources, skill resources within DRDO, if it's not available, we are trying to use these kind of schemes to meet our requirements, and also identification of risks and risk mitigations. So coming to the monitoring and control as part of project management, of course, there are many tools to monitor the progress. We should have change management, as I told, many ways, and employ key performance indicators and also metrics to evaluate the project health, have very good review mechanism. So all this is generally done everywhere in all projects in some way or the other. But the future trends is to integrate all these emerging technologies like AI, machine learning, and sustainability practices that will shape the future of R&D project management, so that it can be made more efficient, innovative, and also environmentally responsible. So through generative AI, it uses deep learning models to analyze large data sets and generate new content, as I was said, that generate the content, analyze the data, and suggest solutions is what generative AI can do, and that can be very effectively used for project management of any R&D system. So this brings technologies, as I said, for analyzing whatever data is already developed using machine learning, so you can have which can forecast the project timelines, allocate the resources more efficiently because of the past data that has already been fed, how a particular, say, developer has taken time in their past. It can say that, okay, this time is fine or not. It also can predict the potential risks. Similarly, language processing can actually streamline the team communication, because many times, as guest of honor was talking today, all work in silos, and there is a difference in the language in which different kind of teams talk. So these can be seamlessly actually linked using NLP, and we can have the automatic reporting and provide insights from the project documentation. So reports can be generated automatically. That will again give you a lot of time to innovate rather than spend time in generating reports for which already the data is available within the tool. Also for predictive analysis, like risk assessment, budget forecasting, and ensuring that the projects stay on track. So these are the AI's fundamentals which can be used in project management. We can streamline repetitive tasks, we can have data-driven insights, and also personalized project management experiences. Say, like I as a manager have got some preferences, some ideas in which I would like to work. The solutions can be thrown by the AI considering what my preferences are. So that will also align towards the shared project objectives. Of course, improved communication, collaboration, and engagement can always be there. Applications, of course, agile and adaptive project management. Again, reskilling and upskilling. So you can say that for doing this activity, what kind of reskilling is required, what should be the training needs. All of them can be again brought out. In some cases, AI may not fully work. You may need a hybrid of combining traditional, that is the waterfall, and agile approaches, and then synchronize all these communications between these. So that hybrid approach also will help. And data and analytics can always be carried out. So different aspects like automation, data analysis, all of them when we list out, what is it that AI-enabled project management can give is given here. What vis-a-vis what the traditional project management would have done. So here the AI-enabled project management will say try to give the project success rate. It will tend to improve this by reducing the errors and delays. It will adapt, say, changing the project dynamics and adapt to the market conditions, because those information in a traditional way we may not have been using it in our analysis at all. But since all those are available within the tools or within the database, they are all picked up and used as a factor, and they all can help. So they are just listed out. I will rush through. So now coming to what is it that in the different project management different steps are. First is for which projects we need to say apply this kind of techniques, say the selection and prioritization of projects. So here the goal is to identify the projects, such projects which are launch-ready projects and that has got the right fundamentals. Because if your technical TRL levels are very high, you identify that and take it up as projects. So it will help. Because many times in an organization, there is flow of many projects that is coming in. Which one to take and prioritize becomes a problem. So use of AI/ML will really help us, because it will say the selection of projects have higher chances of success and deliver higher benefits if the right fundamentals are in play. And this will also remove human biases. Suppose, say, one person was working on a project X, and now there is an organization need to actually prioritize which projects to take. Sometimes the bias can come up, which if you give it to a system, those biases will remove, and it will be a more pragmatic decision that the system is giving. So the techniques that can be used is, again, prediction power. AI can discover the patterns and provide better predictions. And many other techniques like linear regression, neural network predictor, all this can be used. And application is for project selection, resource allocation. So which resource to allocate? If it is a very high TRL level project, which means all the technological aspect is already covered, there you need not put the people who are experts in algorithms. You need more people who can do reuse what is available. So the kind of resource allocation can be carried out in a better way using the system, and of course schedules how to arrive at. So for selection and prioritization, the goals and techniques are there. Similarly, for the project management office, better monitoring has to be done. So, and similar aspects, the technique that can be used are, again, AI for distilled information view, predictive analytics, and also prescriptive analytics for corrective actions if you find there is a problem. And the applications are in real-time monitoring of the project health and aid for the corrective solutions. So similarly, if you want faster definition, planning, reporting, and risk handling, these are the goals, the techniques that we can use, and what are the applications we've already listed out here. Similarly, you can use AI as a virtual project assistant. Say, for example, you have some queries and you have scheduled, say, X, I call it Ravi. In the original one, it was that of a lady's name. Being a woman myself, I said, no, let it be a man's name who has delayed the work. Okay, so schedule Ravi to test that code and allocate, his full time to the task. So the assistant may say, no, based on previous similar tasks allocated to Ravi, it seems that he will need 2 weeks to do the work and not 1 week as you requested. Should I adjust it? Isn't it very good for you as a manager when you're getting such systems giving you prompts to say that, okay, this is what it is. So that you can use it, ChatGPT, the NLP, AI-based and faster summarization and decision making. So here many ChatGPT tools can be used. I am not telling that we are using this as on now, but yes, potential is there. And once it is validated at some level after doing a pilot project, we would like to use these techniques for transforming DRDO to, and we have taken we are in the process of those reforms to transform so that we can perform in a much better way. So here the testing systems, again, the goals are to see that we detect the defects, and we have some self-correcting processes. So which means the test cases that you identify and prioritize and schedule should be in such a way that the most critical test, or which is having more impact on the rework or redesign, should be identified at the earliest. That test case should be run at the earliest so that you identify if there is an error. If you need to correct it, it should take that much time. Finally, it is a good combination between the AI system and the human. So we can use, again, different techniques. So we need not say everything human can do or everything machine can do. It is some aspect of man-in-the-loop control can be provided even in the project management tools. But only one caution: when we integrate all of them, AI into the project management, we need to see that we have careful consideration of the data privacy, and also the ethical implication. Because if the system is throwing out saying that, okay, Ravi has delayed, has that system taken into account the situations under which, say, Mr. X or Mr. Ravi did that particular performance, which a human may be able to do in a better way and understand at that particular time in his life. There were some situations because of which his performance was not good. Doesn't mind that, he is thoroughly like that. So those are many considerations that we need to take it, and they have to be implemented in these systems. So coming to the Vision 2035 of system engineering, which was document was released by INCOSE, there is that purpose is to actually inspire and guide the strategic directions of system engineering across the diverse stakeholder communities. So different challenges are being addressed. One of the main thing that System Engineering Council or the INCOSE has said by 2035 is that we should have sustenance and sustained development. That is, the carbon footprint has to be reduced with every new generation of product that is being brought out, and that is one of the guidelines and which will be actually enforced by 2035. So such guidelines are coming up, which means at the system engineering phase, when you're capturing the requirements, when you're doing the design, these aspects need to be already brought in. So it will also have a smarter, self-organized, and also take into account the global trends in industry, economy, and society. And also it will turn the influence system needs and also the expectations. So it will be, it will also present enormous engineering challenges due to growing complexity, because the systems in future are going to be very, very complex, and decreased predictability with widespread application of artificial intelligence. So what is it that is in future is it will be model-based, of course, and enabled by enterprise digital transformation. It will leverage practices from other disciplines, and also formal system engineering theoretical foundations will be codified so that we can have new research and development for the next generation of systems engineering methods and tools. So these are all from the system engineering guidelines released by INCOSE for 2035. And AI will impact both the systems engineering practice and the types of systems that will be designed by the system engineering community. And of course, emphasis will also be on education, starting with early, with a focus, high focus on lifelong learning, because system engineering, if you see, no academic institution at the graduate or at the postgraduate level has a system engineering as a vertical or as a course, which is actually very important if you need to develop systems which are of very complex. So it also needs to be, the specific recommendations given are that we should have foundational system engineering competencies integrated into college and pre-college curricula, and also many of them, like, it should be promoted for a broad set of domains and also for non-technical, socio-technical needs. And it should be an integrator for many engineering and global challenges. Also, the agendas for industry and government leadership. So we need to demonstrate the value of systems engineering, MBSE, and address dynamic change and uncertainty. Also foundations and research and the tools and digital environment. Mainly what I would like to say is we need to have AI for system engineering, also system engineering for AI, because both are very important. When you are doing SE, you have got so much of data and information that is available. You can always use AI ML to support the practice of SE, and this will create confidence in the design space. So when you're doing a design thinking process itself, you can get multiple options of design using AI, and then you select the best. And principles of learning-based system design is another thing that is important. And especially for an airborne system, the certification of AI-based systems is a very, very big challenge. And so we need to have system-level test beds to study the systems, not just data and algorithms. So the full system engineering from input, process, output, we need to build in the data space also as one of the factor, and redefine the system engineering for AI and AI for SE. So typical development cycle, if you see, is all processes are there. If it is in a not a seamless way, if we use a very good system engineering, project management, use of AI-enabled project management, good virtual testing, and a digital twin, the seamless integration of all the processes will be possible to get a very good automated development life cycle. And just what example I gave, without going for AI, when we used traditional V model and brought up all these things, we have seen that what we delivered in 2017 is Indian AEWNC, that is Airborne Early Warning or AWACS, on an Embraer 145 platform. If you can see, there are multiple countries who has developed such a system, but you see the number of systems, what is there in Indian system, you can see is many more systems that is available in any of the other variants being used by different countries. And I will surely say that the success is due to effective system engineering and program management. So project management of complex systems is really a challenge, and especially it is more challenging in case of an R&D program. We use a concurrent development approach where user, the certification and quality assurance authorities, they are all involved in every stage of the program. And we consciously took aircraft is born as a AWNC system for faster system integration. We planned with the weight, volume, power budget so that there is enough growth potential still available. And effective SE and PM is the success. And use of SE tools also employed from traceability from requirements to test, so that reduce the time frame. And the AWNC system that is delivered to users and inducted into IAF has the maximum capabilities, and it was also operationally exploited during Operation Sindoor as well as earlier in Balakot. And it is, when we delivered, India is the 5th country in the world to have such an indigenous AWNC capability. So the traditional SE and PM itself, we had seen the success. But use of AI in SE and PM, there is enormous potential, and by 2047 for Viksit Bharat, that is the route to go, and that will help us go from Atmanirbhar to innovate in India for the world. I think export is the only key way where we can see that the industries can thrive and get the numbers that is required. So with these few points, Jai Hind, and today being October 8, happy Air Force Day to all the service for dedicated selfless service to the nation, because of which we all actually are able to do the research that we want to do peacefully, because we know there is somebody guarding our borders. Thank you, and Jai Hind. So, thank you for the patient hearing. I think with this I'll just take leave already with the time. Thank you.
Thank you, Dr. Menon, for your deeply insightful keynote address. Your words not only highlight India's remarkable progress in defense and aerospace technologies, but also inspire us to strive for innovation, resilience, and excellence in our own fields. With this, we break now for lunch. We request all participants to reassemble in this hall at 2 p.m. sharp. We will have our next keynote address by Professor Hari Babu Srivastav.